My name is Karuna, and I'm going to introduce Helix today. So before, I want to let you know that English is not my first language. So if you don't hear me very well, please just interrupt anytime, and I will explain it back again. Okay, so tonight I'm going to introducing Helix. I'm going to divide into two parts. The first one is going to be introducing what is Helix and what is Rust, and the second part is going to be demonstration. How do we compare some function made in Helix or some function in native Ruby. So you can access the slides here if you want later. I'm going to give this link again at the end of the presentation. So the first thing is, what is Helix? As you can see here is Ruby and Rust. Does anybody know Rust is or don't know Rust? So I'll explain that later. So it's Ruby and Rust. Helix is native Ruby extensions with our here, and Helix makes writing Ruby classes in Rust safe and fun. Native Ruby extension. So usually I think most of you already use native Ruby extension in the form of FFI. If you use MySQL gem or JSON gem, most likely it's already using native extension. So it's a C code, include codes that needs to be compiled, a C code or C++ code that's compiled, and somehow we can upload that to Ruby interpreter. So for example, you can require a class or something, and it will be loaded. Does anybody never seen native extension? So if it's in Linux, it's going to be .so, or if it's on Mac, it's going to be .dylib, or if it's on Windows, it's going to be DLL. So you are going to load the Ruby, we'll load that, and it will be used, and you can require that. Usually it's made using C or C++. Yeah, this is what I'm talking about. If you want to see more about native extension, if you want to build functionality based on C library, like ImageMagick or SQL, usually there's always a library, and you can combine it with Ruby. If you want to build something like that, you can access it here and see what is the specification, what is the how do you implement that in gem or something. This is the example that I'm talking about. You usually use MySQL. It's going to be connected with MySQL or libMariaDB, depending on what you use. Or if you use PostgreSQL, you are going to use EG-gem and JSON, Unicode. Unicode also have native extension. Be great for encryption, and HarMagic is connected to ImageMagick, the library. So, what is Rust? Rust is a system programming language like C or C++, or I don't know if it's on Windows, Objective-C. I don't know if it's system programming language or not. It's fast. Sometimes it's even faster than C, but it's all depending on how you implement these things. And the most important things that Rust promotes is it prevents faults, segmentation faults, usually caused by overflow or about something that is not in the pointer. For example, if we have something, we have an array of 10 items, but or just say an integer 0 to 255. The data type is 1 byte. So you have a number from 0 until 255. But if you add one more, what will happen? It will overflow and it will cause back. It will cause the thing goes back to 0 and the other memory goes to increase by 1. So it's not good. And because of the way it handles memory, it also guarantees thread safety. Does anybody using program with multiple threads here? Oh, okay. Is it native thread or is it a green thread?
I have no idea which one.
Okay. Okay. So native thread is something that is generated by operating system. For example, if it's on Linux, it's going to be handled by the Linux kernel. But if it's green thread, it's going to be handled by the language, the interpreter itself. For example, if we have green threads in Ruby since Ruby 1.9, anybody using that? You are using that? Threading in Ruby?
I'm not using it directly, I'm using libraries that like
so, yeah. Because Rust is handling memory correctly, it guarantees thread safety. Why thread safety is important? Because concurrency. If you have some value, for example, you have 100, and you have multiple threads accessing that value, you have one thread taking 100, and the other is taking 100 more. What will happen to that number? It's going to be very bad. You don't handle the concurrency very correctly. So because okay, so this is the timeline of Rust. At 2006, some Mozilla employee Hayden Farr make a side project. It's basically a hobby project. 2009, Mozilla heard about the language and they want to sponsor the language. 2010, it's publicly announced, but it's not yet reaching version 1, so it's still in beta. At 2011, it's bootstrapping. Anybody knows what is the meaning of bootstrapping in the system language? It's not bootstrap. So basically, when a compiler like C compiler, GCC or CLang able to create its own compiler using their own language, so it's called bootstrapping. So what happened before we have C compiler? Yes, that's right. So before you have a C compiler, you make that C compiler using assembly. So you can imagine it's a really hard process. Rust able to bootstrap its own compiler in 2011. After that, 2015 May, it reached 1.0. So basically, everyone called that 1.0 is Rust, but and we just had the party 2 weeks ago, 1.17, second birthday. This is quite important. It's backed by Mozilla, a large corporation, not as big as Google or Microsoft, but at least it has a company that is making the language. So it can guarantee the language is going to be stable. And for example, in Go have Go is backed by Google, and Swift is backed by Apple. So I think the future of Rust is going to be quite safe. So this is what a Rust code typically look like. You have some extended, it's like include, including or requiring. You use, this is including, it's like including a job. This one is like requiring or including. And this is the function definition. This is mainline, it's like puts, you define variables, you do something, you generate a random number, and you have to. So the syntax is not that difficult. This is like assigning variable guess, and there's something like it. This is like case in Ruby. So this is a sample of Rust application. A great language is not going to grow up if developers don't like it. Since 2015, Rust already consistently in I don't know, it's most loved language in the Stack Overflow survey. So in 2015, it's number 3. 2016 is number 1 most loved language. And in 2017, it's also the first. So I think programmers can write Rust. Okay, but why do we need to use Rust? We already have Ruby, right? Well, Ruby is great, but sometimes you cannot deny that Ruby is using garbage collector. Sometimes it's making the application really slow. Have anybody have a problem with garbage collector before? Doing some backend processing or something with Ruby. Okay, I'm going to give you an example. Last year, I'm parsing a lot of data from, let's say, Twitter. We use a lot of Sidekick. We use a lot of Sidekick for backend processing, because the way Ruby handles memory, sometimes it cannot reduce the memory that it is allocated. So the memory usage is keep on rising. So what happens if your computer don't have enough memory? Anybody knows what happens? Yeah.
OOM killer helps.
Yeah, OOM killer. What is OOM killer? Anybody knows? So OOM is out of memory killer. So basically, a kernel, the operating system, has a feature to kill the process that is using lots of resource. So if your usage is almost 100% every time, sometimes the kernel is killing your process, and it's not good because you cannot guarantee that your application works perfectly. So in Ruby we have garbage collectors, and we can control it. Even if we manually do garbage collection, it will not reduce the memory usage. So sometimes you have to kill Ruby process and restart again to gain the resource that already been allocated. So that is one of the things that I feel is needed. So why do we need garbage collection? Because this is the reasons that I already compiled. I think the most expensive besides server is programmer. Programmer salary is very high, and that's why programmer time is very valuable. With garbage collection, it makes everything really simple. You don't need to allocate. You don't need to think how you need to allocate memory, and you don't need to think how you deallocate memory. You just need to use. You just need to assign variables, and you don't care about it later. And but it also have a conundrum. By using garbage collection, it makes the application kind of slower because to do garbage collection, the application has to stop for a while and clean the unnecessary memory, unused memory. But also we have like segmentation fault or fatal error. I rarely encounter segmentation error if I'm using Ruby because it's already handled by the interpreter. So you can just, the application can do real panic, but it's not going to just stop the application. It's going to emit some error, record not found or something. But it also will create a memory, what I say is memory hog. It's going to hog a lot of memory. Even if you start garbage collection, it will not release certain things such as symbol. It will be kept in the memory until it's bloated. Next, I'm going to discuss manual memory management. So, what we need is programmer happiness and ergonomics. In a language, if you found that your programmer doesn't use the language happily, if you need to, if you need some time to do a lot of complex language and you need to allocate something manually and you need to deallocate something manually, the programmer will not be happy because it's tedious. Programmer will not be happy. And also there's these things called language ergonomics. For example, in dynamic language like Ruby or Python, you can usually find programmer doing dynamic things, and it will make the programmer happy. This is one of the downside of manual memory management. But on the other side, because you manually manage your own memory, you allocate memory, it's really fast. You allocate something, for example, you need an integer, you allocate that thing in the memory, you tell operating system to allocate something in the memory, and after that you deallocate. It's going to be really, really fast. And also we don't need overhead. If you use something like Ruby, you are going to need overhead because the interpreter itself assigning things to different data structure, it's going to take some memory. So that is why we have manual memory management. The other side of garbage collection. And also, but sometimes the difference between system language and interpreted language is not that high, especially in the IO-bound application. IO-bound application is application that is limited by IO. For example, there's a disk speed, or for example network speed, or connection to database. It's limited by that, and because it's limited, it doesn't matter which language we use. It's going to be the same, almost the same. So the CPU bound is not the limit, but it's I/O. The database connection network at the start. But there's also a programming problem where it's CPU bound. You can implement, for example, image processing in Ruby. You want to convert JPEG to bitmap or convert bitmap to PNG using Ruby. You can, but nobody has ever done that. Why? Because it's usually becoming very tedious and it's going to take a lot of processing power. And also there's big data processing. Usually people don't do Ruby or other language because it requires a lot of CPU power. So that's why it's better sometimes to use system language instead of Ruby. For this one, active record is okay. It's going to be tedious if we use MySQL very directly. But for this one, I think it's better if we use FFI or if we use Helix. So we can see some benchmark of the we can see that using Rust is going to take 4.2 seconds. And it takes 1.8, but using Ruby, it will take some more. This one will be 143 using MRI and 6.6 megabytes for the same thing. So this is comparison of frameworks built using Ruby and other language. Number 9 is Ruby, and we have Rails here. Unfortunately, it's not one of the best. In terms of speed. Okay, the next question is why we have to use Rust. We can just use C or C++. One thing that Rust promotes really well is memory safety. It designed the language so if you allocate something, you have to make sure the lifetime of the object itself. So it guarantees memory leak. From memory leak, it guarantees no memory corruption unless it's maybe hardware problem. There's no accident on nil. Sometimes you query something and you get nil, and it creates a lot of problem in the application if you forget to handle that. But with Rust, it's kind of guarantee that it will always be safe. In C, this one is pointer is the one that we use usually in C or C++. But in Rust we use the thing called borrow checker. So it checks the variable if it's already assigned, and you cannot have another variable that is allocating to the same memory place. So it guarantees that you will not be able to mess up the value of the variable. And it will do automatic deallocation. With C or C++, you have to reallocate manually. But with Rust, it will be automatically deallocated when it's out of scope, when it's out of block. So it should be easier to handle memory. And that's this thing lifetime. It basically say when a variable can leak. Okay, because of it guarantees memory safety, it will create a security problem. It will not be, you cannot possibly overflow an integer. For example, if you have 64-bit integer, you will not be able to overflow that. If you overflow that, the compiler will complain. It will check everything. For example, does anyone remember heartbleed? Heartbleed?
Yeah.
Okay, it's a problem with SSL. After last year, 3 years ago. So basically, you have to change the SSL because of this problem. This analysis says that if we use Rust, it will be more safe and it will prevent a lot of problems like this security problem. Okay, in terms of speed, you can compare. SERDE is serialization, deserialization. Basically, so we can see the benchmark here. For Rust it's 4.2, and for this one of the fastest C library for processing JSON. It's 0.7 seconds, so it's kind of fast. So you can compare Rust with other programming language. I think this is also one of the benchmark. K-nucleotide is one of the game. Simple game. You can see the solution using Rust is for one of the fastest compared to C and other language. You can see the bigger. The faster one. And one of the things that is really great when you are using Rust is there's a lot of people that is involved in Ruby for a long time that is also involved in Rust. For example, Irene Katz, I think he maintains Bundler and contribute to Ruby Gems. Right now he is one of the core developers for Rust. He is maintaining Argo package management for Rust. And Steve Wozniak is making Rust documentation. I think he contributes to Rails before one of the, I don't remember, but he's kind of big in Ruby community as well. If we use Rust, it's going to be best of both worlds. We can use native system application. We can use native speed, but also we wrap that in Ruby. So it's kind of best thing. We take something good from system language and we take something good from native language such as Ruby. We can do that in both ways. FFI, native extension that I've been talking about, and Helix. So I'm going to do some demo making Helix. The first thing should be install Rust, but I already have Rust in my library. If you want to install Rust, just do something like that. It's called Rust. It works like RTM or RBENV or whatever Ruby version we use. It's recommended to use this one. Or if you already have one installed, you can just use this. You can just update. I'm going to make an application. Let's add some jump first. Can you guys see this clearly? Or do I need to zoom? Can you guys see clearly? After installing the dependencies, let's make a let's install root for. So I'm going to compare two things. The first thing is going to be parsing CSV using Ruby, and the second one is parsing CSV using Helix. Next, let's add some controllers. Let's make a new helper for bench part meetings. Next thing I'm going to implement I need to copy first the file. So if you take a look, it's taking about 1 or 2 seconds copying that file. Let's implement the things in Murti first. We have initial variables and we process the CSV. Basically, we just want to add ID row and make it integer. The CSV file has about 180,000 lines with, I don't know, the IDs. So we are going to get the time from the range and we are going to get the sum from the method. Now we are going to implement the Helix one. Let's generate some Helix code. We already installed it, so let's generate. Let's generate Helix. Okay. I'm going to name it CSV reader. create a bunch of things inside. There's this folder. It's basically creating. If it's in the Rust, it's going to create a Rust library. This is where the native extension going to be. This is where the source for the library going to be, and we see that we have it already prepared. Hello method. This is Karuna is like right. If a node is package JSON, the configuration. This is your spec and the rec file. So we already have the hello world. You can see we have CSV reader class and we have hello class, and we can just write it the console directly. We can do IRB. It will compile the extension directly, so we can just directly use in the IRB. So it works. So let's add some things. So let's implement the CSV reader in the class. First thing first, we need when we make things, we need to ensure that it's good. So let's add dependency. As usual, we are making tests. We want to make sure it returns integer. Let's see. So we are going to have this function from ID, and the parameters is going to be file name, and we expect the result to be integer. So let's try. It's going to fail. Okay.
You need to CD up to your root directory.
We need to compile the. So let's implement first.
The I6 for. You type I6 for.
So yeah, there's a couple of data types primitives. It's integer 64-bit. There's another data type that is 16-bit or 32-bit, whichever, whatever your requirement is. There's also U, not un. U means unsigned, so it's always positive. Because we haven't compiled the application, the native extension. I think just yeah, it's biggest typo. Can I see here? So when you do something dangerous, it's called fighting with the compiler. The compiler always complains if you do something, if you cannot do this, if you cannot do that. The compiler will always tell you, for example, if you make something dangerous, you break it.
Starting to run out of time.
Yeah, sorry. Let's just okay, this is a problem. I cannot continue the demo. just show the slides. So after that, you add the dependencies in the cargo promo. And in the library, you implement the class. Basically, it takes the file name. You have total variable. You read the CSV file name, and each row it will just add to total, and it will return total. After that, you implement in the Ruby controller Helix, something like this. The same with Ruby, and you make save view. Okay, I think I still have a backup folder, so let's see if we can use that and see the result. So it's going to take a while. Let's try the Helix because it's
SMT.
yes. So it's just take about 2 seconds. 2 seconds. Well, the Ruby is going to take around 30 seconds. I don't know why this is wrong. I think it's overflow or something, but it's going to take 30 seconds to pass around 180,000 lines of CSV, but for Helix it's just going to take 2 seconds. Yeah, sorry for the coach, I don't know why. This is my personal thought. Rust is a nice, neatly designed language. If you want to add something, you have to use RFC, request for comment, and the package manager is nicely designed from the beginning. For example, in other language, you have to struggle with dependencies. You have to put something in folder, load directly, and manage the clone directory, manage the dependencies manually, and after a while, people start to think if you need package manager and there's a bunch of people implementing, soon you have 30 people doing package manager and there's no de facto package manager, but it's finished neatly designed from the beginning, so it has cargo and you can do tests very nicely. You can do inline tests, something like this, and also you can use Markdown as the documentation in above the function. You can use Markdown here, and they really care about editor support. They already create these things for editor. You have a marker, you have go to symbol. And what I really like is they really care about computer science and the real application and the real implementation in the real world. And the last thing, it's hard. You have to fight with the compiler every time. Just like that. But the result is quite nice. It's quite fast. So if you want to report, this is some results. This is the class language itself. This is the book. Everybody is recommended to read the second edition of the book. And if you want to try in the browser as the example, and this is the documentation for Helix itself. And and also there's for introducing Helix. Yeah, and little bit about me. This is my LinkedIn. If anybody wants to comment, and this is my GitHub. I have some experience. So I'm going to give you link back to the presentation if you need this. So if you need the presentation, thank you. And by the way, I have 3 stickers. First thing is cookie. Anybody wants this? No? So if you want, you can come to me. And there's Rust. And there's also C++. Do you want stickers? Please. Thank you.
Do you want any questions?
Anybody have questions? Yes.
Do you heard about Crystal language?
Crystal, yeah,
compared to Rust.
I heard about that, but their goal is not compatibility with Ruby. The syntax is like Ruby, and they have really nice syntax, but I never heard so much about that.
What kind of things have you used Rust for in the Ruby version?
Just this demo. I already learned about the whole syntax and I want to use it in production, but there's not enough chance to use it. Anybody else?
Do you know the real world example of using Helix?
Okay, I think it's been used in Skyler, the one that creates this, but the Rust itself is used in, it's getting used in many companies. Mozilla already use several of that code in the Firefox, and Dropbox already start using that. Oh yeah, and the editor that I use, Visual Studio Code. The search is using readgraph. It's implemented in Rust, so it's way faster than graph. The search is, but for bridge with Ruby itself, no, not so much. Anybody else? No? So, one more.
Do you think it's better invest in some kind of like extension for Ruby, or is better to connect things on the different layer? Let's say that I want to execute some code that is required to be really fast. I can write some C application, for example, or any language that is like system language level, and communicate through, let's say, Redis with system that is basically in Ruby. Don't you think that is just wasting of time in
Yeah,
connecting directly?
So if you use Redis, there's a anti-pattern. So you connecting everything to database is not a good idea. I forget the name of the anti-pattern, but it's there. So there are better ways to do that. For example, like
It's just example. Just say that it's maybe are better ways. Sometimes even like killing the process like every 2 days because it's taking the whole memory is a way to deal with business, right? So
I think it depends on the use case. There are things better implemented. For example, video processing or things implemented using native. But there are also things it's better used. There are things better implemented using dynamic, maybe using Redis or go through database or go through socket connection. I think it all depends on the use case. Okay, if there's no more question, thank you.